Hi to everyone, myself Dr. Dhananjay Rao, working as assistant professor in the Department of Chemistry. Today I am going to discuss about secondary batteries. In that I am going to explain lead acid storage battery and lithium ion battery. In this session I am going to cover these topics. What is primary battery, what is secondary battery, what is lead acid battery and its applications, and what is lithium ion battery and its working and its applications. Primary batteries. What are the primary batteries? These are non-rechargeable and single-use and to be discarded after use. What are the primary batteries? Primary batteries are non-rechargeable. Means the chemical reaction not reversed in the primary batteries and it can be used only single time and it discarded after use. After the application, after the working of these primary batteries can be discarded. These are non-reversed and are less expensive. These are primary batteries are non-reversed and cost wise these are less expensive. Often used in ordinary gadgets like torchlights and watches and toys. Primary batteries are used in torchlights, watches and toys. These are very less expensive. What are secondary batteries? These are rechargeable and multi-cycle use. Secondary batteries are rechargeable and we can use multi-times. After every use, the electrochemical reaction could be reversed by external energy supply. Secondary batteries we can use multi-times and in this electrochemical reactions are reversed by applying the external energy. Means we can recharge after discharging. The examples of secondary batteries are lead acid cell and nickel cadmium cell. The lead acid cell and nickel cadmium cell comes under secondary batteries. The difference between primary and secondary batteries. What are the difference? We'll see. Primary cells and secondary cells. Primary cells are rechargeable and single use and discarded after use. Already I have explained. Primary cells are non-rechargeable, single use and discarded after use. But secondary cells, these are rechargeable and we can use multi times. Secondary batteries are rechargeable and we can use multi times. In the primary cells, cell reactions is not reversible. In the primary cells, cell reaction is not reversible. But in case of secondary cells, cell reaction can be reversed. In secondary cells, cell reactions can be reversed. The primary cells cannot be rechargeable. Primary cells cannot be rechargeable. But in case of secondary cells, these are rechargeable. After discharging, we can recharge the secondary cell. The primary cells are less expensive. Cost-wise, the primary cells are very less expensive. But secondary cells are expensive. Primary cells can be used as long as the material are active in their composition. In the primary cells, the chemical material is active, then only that will work. After that, it will discarded. But in case of secondary cells, it can be used again and again by recharging the cells. By recharging the secondary cells, we can use multi times. The examples of primary cells are lithium cells and Lagrange cells comes under primary cells. But secondary cells, lead acid cell and lithium ion cells. This comes under secondary cells. These are rechargeable. These are non-rechargeable. Primary cells are non-rechargeable. Secondary cells are rechargeable. I am going to explain secondary batteries. In that I am going to explain lead acid battery. What is meant by battery? Battery consists of two or more than 3 electrochemical cells. Battery consists 2 or more than 3 electrochemical cells. Then that is called battery. The lead acid battery was invented in 1859 year by French physicist Gaston Plante. Lead acid battery was invented by Gaston Plante in 1859 year. It is the oldest rechargeable battery and it is secondary battery. Lead acid battery is secondary battery and it is old one. In the lead acid battery, one electrode is lead and the other electrode is made up of lead peroxide. In the lead acid battery, one electrode is lead and other electrode is lead peroxide. Number of lead plates are connected in parallel and the number of lead oxide plates also connected in parallel. I already explained. Lead acid battery consists of more than 2 or 3 electrochemical cells. But lead acid battery consists of 6 cells. 6 electrochemical cells. 1, 2, 3, 4, 5 and 6. 4, 5 and 6. 6. Each cell consists of one electrode lead, other electrode is lead peroxide. Similarly here, this one electrode contains lead and lead oxide. Continues like this. All lead anodes are connected parallelly. All lead peroxide electrodes connected parallelly. Number of lead pairs are connected in parallel. Similarly, the number of lead acid pairs are also connected in parallel in lead acid battery. The lead plates fits between the lead oxide plates. In between two lead peroxide electrodes, one lead electrode is inserted. These plates are separated by insulator. Each cell is separated by one insulator. The insulator may be wood, fiber, glass or rubber. The entire combination is immersed in 20 to 21% dilute H2SO4. These all electrodes are immersed in 20 to 21% dilute H2SO4. Means 20% H2SO4, 80% water. This is the lead acid battery. This is lead. It acts as negative electrode. Similarly, this is lead peroxide. It is positive electrode. The electrolyte solution is H2SO4. The main active materials required to construct the lead acid battery. What are the main materials required to construct the lead acid battery? We will see. First one is lead peroxide that acts as cathode in the lead acid battery. The second one is sponge lead that acts as anode. The electrolyte solution is dilute sulfuric acid. Lead peroxide that is used. We will see. The positive plate that is cathode is made up of lead peroxide. The cathode is made up of lead peroxide in the lead acid battery. This is dark brown. The color of this cathode is dark brown. It is hard and brittle. The lead peroxide electrode is very hard and brown color and it is brittle one. The sponge lead. The negative plate anode is made up of pure lead. The anode electrode in the lead acid battery is made up of purely lead or spongy lead in soft sponge condition. It is in very soft condition. Dilute sulfuric acid. Dilute sulfuric acid is used for lead acid battery as a ratio of water and acid. Water ratio is 3 and acid ratio is 1. The dilute H2SO4 we use for the electrolyte in the lead acid battery. 3 ratio water and 1 ratio H2SO4. The lead acid storage battery is formed by dipping lead peroxide plate and sponge lead plate in dilute sulfuric acid. We have to dip lead electrode and lead peroxide electrode in H2SO4, dilute sulfuric acid. During discharging, lead acid battery acts as electrochemical cell. During discharging means when we connect load to this electrode, it acts as this lead acid battery acts as voltaic cell or electrochemical cell. The electrochemical reactions involved in discharging of lead acid battery. What are the reaction occur while discharging the lead acid battery? We will see. When we connected lead acid battery to the load, the lead acid battery get discharged. Then we will see what happens in the lead acid battery. In dilute sulfuric acid, the molecules of the acid split into positive hydrogen ions and negative sulfate ions. The electrolyte which is there, dilute H2SO4 is there. Dilute H2SO4 is dissociated into H plus and SO4 minus 2 ions. At anode, oxidation takes place. What is anode? Anode is lead. Lead reacts with sulfate. sulfate comes from H2SO4. H2SO dissociates into H2H plus and SO4 minus 2. The SO4 minus 2. The lead reacts with this SO4 minus 2 gives lead sulfate. Lead sulfate and it releases 2 electrons. What happens? The anode lead reacts with H2SO4 gives lead sulfate and releases 2 electrons. Means at anode oxidation takes place. And what happens at cathode? Cathode means lead peroxide. Cathode means lead peroxide. This lead peroxide takes the electrons from this anode and for H plus. H plus ion also it will produced by anode. This H plus ions reacts with lead peroxide and sulfate. It forms lead sulfate and water. Means the lead peroxide undergo reduction forms lead sulfate. At anode, the lead reacts with sulfate ions, forms lead sulfate and releases 2 electrons and also 2 H plus ions. At cathode, the lead peroxide undergoes reduction and forms lead sulfate and water molecules. The net reaction is, how you will get net reaction? PbSO4 minus 2 gives PbSO4 plus 2 electrons. PbO2 reacts with 2 electrons, 4H plus and SO4 minus 2 gives PbSO4 and 2H2O. Add total reactants and add total products. Then we will get the net reaction. The net reaction is lead reacts with lead peroxide in presence of sulfate ions and H plus ions. It gives lead sulfate and it produces water. This is the net reaction occur in case of discharging of lead acid battery. The electrochemical reaction involved in charging of lead acid battery. While charging, previously we have seen discharging lead acid battery reactions. This is the the electrochemical reactions involved in charging of lead acid battery. Two electrodes are there, lead and lead peroxide. This is anode and this is cathode. These are connected to external energy or external battery. Then the electrons flow into these electrodes. This lead acid battery get charged. During charging, lead acid battery acts as electrolytic cell. During discharging, the electrochemical cell acts as electrochemical cell or voltaic cell. But during charging, lead acid battery acts as electrolytic cell. At anode, what happens? See, at anode, oxidation takes place. Lead sulfate reacts with water and produces lead peroxide and releases 2 electrons and H plus ions and sulfate ions. At anode, lead sulfate reacts with water, gives lead peroxide and 2 electrons and produces H plus ions and sulfate ions. Means this combines to give H2SO4. Means at anode, the electrochemical reaction produce sulfuric acid again. At cathode, what happens? The lead sulfate takes 2 electrons from this anode and forms lead and sulfate ions. At anode, oxidation takes place. Lead sulfates react with 2 molecules of water, gives lead peroxide and 2 electrons and it produces sulfuric acid. Similarly, at cathode, the lead sulfate reacts with 2 electrons, produce lead and sulfate ions. The net reaction is the lead sulfate reacts with 2 moles of water molecules. It produces lead and lead peroxide and sulfate and H plus. This combinedly gives sulfuric acid. While discharging, the lead acid battery produces sulfuric acid. While discharging, it dissociates sulfuric acid and it in the discharging reactions, the lead acid battery consumes H2SO4. H2SO4 it takes and forms lead sulfate. But while charging the electrolytic cell, the lead sulfate reacts with this H2O, forms H2SO4. Means while discharging, H2SO4 concentration decreases. While charging, the H2SO4 concentration increases. During discharging, H2SO4 is consumed and its concentration decreases. See, while discharging, the H2SO4 is consumed by lead, forms lead sulfate and form water. Means the concentration of H2SO4 decreases while discharging lead acid battery. During charging, H2SO4 is regenerated and its original concentration is restored. While charging, the lead sulfate reacts with water. It produces lead and sulfuric acid. Means the concentration of the sulfuric acid increases while charging the lead acid battery. The voltage of each cell is 2 volts. In general, lead acid battery consists of 6 cells. Lead acid battery. This is the original lead acid battery. See, 1, 2, 3, 4, 5, 6. 6 electrochemical cells are present in the lead acid battery. Each electrochemical cell produces 2 volts. 2 volts current, and total current produced by lead acid battery is 12 volts. Applications of lead acid battery. The lead acid battery can be used in telecommunications or telephone exchanger. It can be used in power stations and television systems, and it can also be used in standby supplies and UPS, electric vehicles, emergency lights, and railway mains. We can use lead acid battery in these applications. What is the advantage of this lead acid battery? The low maintenance and low cost. The price of the lead acid battery is low and the maintenance also very easy. Disadvantages of lead acid battery. It is heavy in weight and load is not environmentally friendly. Lead is not environmentally friendly. The battery weight is very high and lead is poisonous to the environment. So these are the disadvantages by the lead acid battery. Next, lithium ion battery. This is also a secondary type of battery. The main active materials required to construct lithium ion batteries are a positive electrode. It contains layers of lithium metal oxide. It acts as cathode. One is, what are the main materials in the lithium ion batteries are a positive electrode, which is a positive electrode we can call as cathode. It is made up of layers of lithium metal oxide. Lithium metal oxides. Metal may be cobalt, nickel, extra. Okay, lithium metal oxide. It acts as cathode in case of lithium ion battery. A negative electrode, we can call as anode. It is made up of layers of porous carbon. The negative electrode is made up of layers of porous carbon. An electrolyte solution is organic polymers like polypropylene and polyethylene. We can use as electrolytes in this lithium ion batteries. Construction of lithium ion battery. How we can construct the lithium ion battery, we will see. The positive electrode is typically made from layers of chemical compound called lithium cobalt oxide. This also acts as cathode, already I said. The positive electrode is made up of layers of lithium metal oxide. Example, lithium cobalt oxide acts as cathode. The negative electrode is made from layers of porous carbon or graphite. The negative electrode is made from layers of porous carbon or graphite. Both the electrodes are dipped in lithium salt electrolyte separate. Lithium salt electrolyte. These two electrodes are dipped in lithium salts. Electrolyte solution is lithium salts, and these are separated by separator. These are made up of perforated plastic and allows lithium ions. See, this is the lithium ion battery. This is anode. It is made up of layers of porous carbon. This is cathode. It is made up of layers of lithium metal oxides. Example, lithium cobalt oxide. Okay. These are dipped in lithium salts. Any lithium salts acts as electrolyte solution. Then these two are separated by one separator. It is made up of perforated plastic. It allows only lithium plus ions through this separator. Okay. Only the separator allows the lithium plus ions through them from anode to cathode or cathode to anode. The working of lithium ion battery. See, while charging the lithium ion battery, what are the reactions occur? We'll see. During charging, lithium ions flow from the positive electrode, that means lithium cobalt oxide, to the negative electrode, graphite, through the electrolyte. While charging, lithium ions flow from the positive electrode, that is lithium cobalt oxide, to the negative electrode, graphite electrode. See, this is the lithium ion cell or battery. This is anode, graphite. It is made up of graphite or C6 porous carbon, and this is cathode made up of lithium metal oxides. These are connected to external. We are applying means we are charging means we have to connect it to the external batteries. The current flow through this circuit, and the current enters into the positive or cathode lithium metal oxide. This lithium metal oxide undergoes at cathode. Lithium metal oxide forms lithium plus and metal oxide and releases electrons. The current flow through this cathode and lithium metal oxide undergo some chemical reaction. It forms lithium plus and metal oxide and releases electrons. These electrons flow through this circuit and reaches anode, and the lithium plus ions are released at this cathode. The lithium plus ions are travel through this separator and enters to the anode and settled at anode. Okay, at cathode, lithium metal oxide metal undergoes decomposition, forms lithium plus and metal oxide and electrons. At anode, what happens? See, at anode, what happens? At anode, what is there? Porous carbon is there. The porous carbon reacts with these lithium plus ions. The lithium plus ions reach to this porous carbon. This porous carbon reacts with this lithium plus ions and electrons. It forms lithiated carbon. It forms lithiated carbon. Well, when you charging this lithium ion batteries, we have connected to the external battery. The power supply, the current flow through this circuit and reaches the cathode. The cathode made up of lithium metal oxide. So the lithium metal oxide reacts and forms lithium plus ions and metal oxides and releases electrons. These electrons flow through this circuit and reaches anode or graphite. Similarly, the released lithium plus ions are moving through this separator and reaches the anode or graphite electrode. This at anode, porous carbon is there. This porous carbon reacts with lithium plus and these electrons. It forms lithiated carbon. The net reaction is the lithium metal oxide reacts with porous carbon, forms metal oxide and lithiated carbon. This is the reaction occurred at lithium ion battery while charging this. At cathode, lithium metal oxide forms lithium plus ions and metal oxides and electrons. It releases electrons. At anode, what happens? At anode made up of porous carbon. This porous carbon reacts with lithium plus ions and electrons, forms lithiated carbon. The net reaction is lithium metal oxide reacts with porous carbon. It forms metal oxide and lithiated carbon. This is the net reaction occurred in lithium ion battery while charging. What happens while discharging the lithium ion battery? See, the lithium ion battery is connected to the load. The lithium ion battery is connected to load. Then this lithium ion battery gets discharged. Okay, while discharging, what are the reaction occur? We'll see. During discharging, the lithium plus ions flow back through the electrolyte to form negative electrode to the positive electrode. During discharging, what happens? The lithium ions flow back. While charging, the lithium ions comes to this. While discharging, these lithium plus ions moving to the cathode, moving back through the cathode, and it from the negative electrode to the positive electrode. While charging, the electrodes comes from positive to the lithium plus ion moves to plus to minus, means cathode to anode. While discharging, these lithium plus ions again moves to the anode to cathode through this separator. The electrons flows from the negative electrode to the positive electrode. The electrons flows from the negative electrode to the positive electrode. The lithium plus ions and electrons combine at positive electrode. The electrons comes from anode to cathode. Similarly, the lithium plus ions also comes from anode to cathode. This lithium plus ions and these electrons combines together at cathode forms lithium. The lithium plus ions reacts with electrons forms lithium. What happens at anode? We'll see. The lithiated carbon reacts at anode. Lithiated carbon undergo reaction, forms porous carbon and releases lithium plus ion and electrons. At anode, what happens? The lithiated carbon formed at while charging. This lithiated carbon while discharging, it undergo reaction. It forms porous carbon and releases lithium plus ions and electrons. The electrons moves through the circuit to the anode to cathode. The lithium ion plus moves from this anode to cathode through this separator, and these two are met at cathode forms lithium. At cathode, what happens? The metal oxide and the lithium plus electrons together it forms lithium metal oxide. At cathode, already metal oxide is there, and this lithium moves through this separator, and electrons comes from the circuit, and together this forms lithium metal oxide. The net reaction is metal oxide reacts with lithiated carbon, forms lithium metal oxide and porous carbon. Then what is the net reaction? The metal oxide reacts with lithiated carbon, forms lithium metal oxide and porous carbon. The advantage of the lithium ion battery. Lithium ion batteries are releases high voltage and lightweight batteries. What is the advantage of the lithium ion battery? These are very lightweight batteries and releases high voltage compared to the lead acid battery. It is smaller in size. It produces 3 times more voltage than the nickel cadmium batteries. It produces 3 times more current compared with the nickel cadmium batteries. Uses of the lithium ion battery. It is used in cell phone, note PC, portable LCD TVs and semiconductors driven audio, etc. The lithium ion batteries can be used in cell phones, PCs and LCD TVs and semiconductors and etc. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.